Hello, welcome. This is my Leetcode series of solving algorithms, data structures. Okay, so for the first question is find the two sums that equals to a target. So the question goes, given an array of integers, norms, and an integer, return indices of two numbers such that they add up to a target. You may assume that each input has would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. Okay, so basically 2 and 7 is going to be 9. So our output is going to be an array of zeros and 1. Same thing goes for 2 and 4 is going to be 1 and 2 and thereby. So the note says that the return array must be malloc assume color calls free. So I'm writing this in C. So first, we allocate memory for results, and that would be equal to cast and call malloc size because we're returning to we allocate to size of integers. Right. So that's the first step. Second, we look through the first array and to get the first digit that we're comparing with. So let's int I is equal to 0, I is less than our num size, which is already given to us. Okay, and then we are close to the loop. A second is for int j, looking through, so be looking after I to compare. So you're comparing 7 and 2, 11 and 2 and 11, 2 and 15. We compare 7 and 11, 7 and 15. And that's how we keep going. So this would be I plus 1 because we want to come look after I and we loop as long as num size is a big time right here. So so if nums I plus nums j is equal to target, and we found that answer, we can result 0 is equal to I. That's the first one. That's the first one here. And result J. That I have to be honest, I have some this before because to be honest, I'm not really that camera confident yet. So to stop me from shaking and like messing up the test. Wait first. So there, I'm going to submit return result. And for a reason we got the footnote size, so we have to allocate memory. So we have to return the size of we have to allocate this for the return size. Return size was equal to 2. And then after everything we return false. Basically it's so my and here as well. I'm missing a semicolons. No, sorry. Okay, so submit this. Let's get accepted. Like I said, guys, I have solved this before. So now back to the description. It says that can you come up with a with an algorithm that is less than O of n squared in complexity? So we can solve this again by using a hash map. So what that does is that instead of instead of us to look through the array, we find like the complement. So for example, if we have 2, we subtract the target from our first number and then check for the complement and then move on. If and then when we reach 7, we do 9 minus 7. And if there's a complement already in the hash map, we just return them instead of having to like look through twice. Okay, so we have like look to our first array. We create a hash map struct, we type def struct. Then we have int to their key, and then we have int to their value. So then we have this as a hash entry. So we allocate a hash table, hash entry equal to hash table. So we allocate the size of the size for the struct of our hash map, hash table, which will equal to the norm size. Okay, so if we look through a first array, int I is equal to 0 and I is less than norm size, and then I plus plus. Then now we we have a value called complement. Complement will be equal to target minus and norms I. So that would be 7. That would be target as 9 minus 2. Will be storing. So we now check through the hash map for, let's say, int j is equal to 0. It's going to look through the hash map to check if the complement is already there. We look as long as j is less than I, but we just only want to look the amount of times I has gone through, and then we have j dot rest. So we say if a hash map if a hash table j dot value is equal to complement, then the personal result, the return result is equal to result I 0 is equal to I, that's a key, first key, and then result 1 will be equals to hash map key, hash maps key, after hash table, right? So we get an answer there, and then we return result. So we do the allocation of memory stuff for return size. To, to, okay. So and then we return that. Then we add to a hash map if there's no result found. A hash map, a hash table. I keep saying hash map equals to I the key will equal to I and hash table the value equals to nums I. And there we have it. We run a code. Sorry, I use just semicolons coming from JavaScript. Okay, so that is it. Hit submit, and this takes less time than the other one. It's 48 minutes. All right, so that's it.